Review Minds. Welcome back to our YouTube channel known as Reviewed Chemistry. Today, we'll be looking at isotopes. We'll be talking about atoms in our previous video, but we'll be looking at isotopes. Remember in our last video, I told you that an atom is the smallest particle of an element or a substance or a species that can take part in a chemical reaction. And also reminded you in our last video that some elements in the periodic table are determined by what? By their atomic numbers. Because in the periodic table, we have the first 20 elements for the younger minds, from 1 to 20. That's from hydrogen, helium, lithium, beryllium, boron, to potassium and calcium. That is making the calcium is what? The 20th what? Element in the periodic table. But today, here we talk about isotopes. When you talk about isotopes, what do you comes to your mind? What comes to your mind is that there are some elements in the periodic table that have different mass numbers, but they have the same atomic number. Now, if you remember that, if you go back to the previous video I made, when it comes to atomic number, proton number, and electrons, I told you that these elements, these numbers, are the same. When you're talking about proton number, you are talking about what? Electrons. Number of electrons of the atom. I'm also talking about what? The atomic number of the atoms. Of which the atomic number determines what? The position of the elements in the periodic table. What is the periodic table? Just the arrangement of what? Electrons according to the word increasing atomic numbers and atomic mass. Through what? The columns and rows. But here we'll talk about what? The isotope. Those fractions, or how I put it, those characteristics that determine what a particular element. Let's say, for example, chlorine. Chlorine has an atomic number of what? 17. But in the periodic table, chlorine has atomic mass. In the atomic mass, we say that what? Chlorine has two masses. That is where the isotope comes in. We talk about what? The difference in mass number, but the same atomic number. Also remember that some students make different mistakes when it comes to isotopes. They say that isotope is a process. An isotope is not a process. It's an existence or a phenomenon of that particular atom. It's not a process. Isotopy is not a process. It's what? The phenomenon or the existence. Now, which is why you see here, I said what? The isotope, and isotope is a phenomenon or an existence. Whereby an atom has what? The same atomic number, but different atomic mass. They can also say that they have the same proton number and what? Electrons. So, if you talk about these isotopes, the atomic number tells you the exact position of that particular element in the periodic table. So, which why I say there, note that the atomic number determines the key factor here determines the position of an element in the periodic table. Without the atomic number, you will not know the exact place where that particular element belongs to. Now, here are some examples of an isotope. Here you have chlorine. The symbol of chlorine represents Cl. Capital letter C and small letter L. Now, most of you may be asking why I'm writing, I said capital letter C or small letter L. Now, when you have an element with two alphabets, when you have an element with two alphabets, the first alphabet will carry a capital letter, while the second alphabet will carry a small letter, which is why you see that chlorine here have capital letter C and small letter L. And the atomic mass of chlorine is what? 35. While the atomic number is what? 17. And the isotope is what? The atomic mass when it comes to the isotope is what? 37. And the atomic number is what? 17. Also, let's go to carbon. The atomic number of carbon is 6, while the atomic mass is what? 12. The isotope is here is that atomic mass of carbon here becomes what? 14 instead of what? 12. Because we're talking about what? Isotopes. So isotope here becomes what? 14, and atomic number becomes what? 6. The same applies to what? Oxygen, which has atomic mass of what? 16, and atomic number of what? 8. But the isotope is what? 17 and what? 8. Did I refresh your mind? Now, let's say you're a beginner in the aspect of what understanding simple chemistry. I think I have opened your mind to these few things. This is the isotope of what? Carbon. This is the isotope of what? Oxygen. And this is the isotope of what? Chlorine. These are their masses. Now, when we talk about masses, we simply talk about this in the respect of what? Remember I told you that what? A mass number is what? The sum of the atomic number and what? The neutron what? Number. That is what? That's what gives you what? The mass of what? An electron or the mass of an element. I believe that I've revealed your mind in respect to what? What isotope is all about. And in our subsequent videos, we make it similar ways how to calculate the isotopes, how to calculate the proton numbers, the neutron numbers, and how to calculate the relative atomic mass of what? Of an element. Don't forget to like, subscribe, and comment on our YouTube videos. See you next time.